but it goes back to the basics that I said, aggression and patience. It's a different equation with thrust vectoring. So you can do some phenomenal maneuvers with thrust vectoring. You could go up and turn around and so on, but your opponent is going to be watching you do this and clapping, but you're up there as a constant target and he's shooting you down.
When you think of giants in Air Force aviation, you might recall names like Chuck Yeager, Bob Hoover, maybe even Robin Olds or John Boyd. But do you know the name Rogers E. Smith? Well, you should, because he is a former Royal Canadian Air Force pilot who then spent many years in the Air National Guard, retiring as a lieutenant colonel. He then flew for NASA for a number of years, flying the X-29, X-31, F-15, SR-71. And most importantly, today, he is my guest here on the Fighter Pilot Podcast. Raj, welcome to the show.
Yeah, Roger's fine, and it's a pleasure to be here.
But
Thank you.
It is Rogers with an S. That takes...
It is. It's my grandmother's surname, so I have two last names.
Rogers Smith. That's why the E helps.
Yeah, my guard buddies would say, what is your real name? Is it Rogers Myth or Roger Smith? So it's Rogers.
All right.
But Raj is fine.
Well, what about Chuck Yeager and Robin Olds and Bob Hoover and all these guys? Are you okay with me throwing your name in with that group?
Well, I doubt that I'm right up with them, but they're names that I know, and one that I flew with, that's Chuck Yeager. Gave him a flight later on in his time. He came to the supersonic flight, the sonic boom at every Air Force Day at Edwards. And so we invited him at the 50th anniversary of supersonic flight to talk at NASA, and how I got him to come was promising him a ride in the front seat in an F-18.
Really?
So
wow.
we did that.
Exciting.
Great pilot.
Oh, good. Well, I imagine you have tons of stories. That's why I'm so glad we finally made this work. Turns out we only live less than a mile apart.
No, that's amazing.
So I drove over to pick you up to come out here, but I could have walked because we're just down the street. When you're in town, I know you have other places we'll talk about.
Fine. But enjoy it.
Well, I'm really looking forward to this. We met through our mutual friend, Billy Flynn. And so I told him last night we would be discussing your career and SR-71 and whatever comes to mind. So he sends his regards. You probably keep in better touch with him than I do.
I do, and he came as a Canadian exchange to the test pilot school first at Edwards. That's how we met.
All right.
And then he did ultimately fly. He flew the Harv, the thrust vectoring F-18. He flew with us. Yeah. We got to fly the thrust vectoring F-16 as a result of the cooperation.
Wow.
And he was squadron commander of the same squadron I was in the Canadian Air Force, 441 Squadron.
Fantastic.
So I know him well.
Good.
Yeah.
Well, let's go back to the beginning, Raj. What got you, or who got you interested in aviation in the first place? I mean, a lot of kids, right, stare up at the sky and look at airplanes and think that's amazing. I want to do that. Some want to be firemen or whatever else. But aviation bites a lot of kids. And how did it for you?
Well, I had an uncle. I grew up and was born in Western Canada in a place called Dawson Creek, way up in the north. My father joined the Air Force in the Second World War and was shipped off to England as an armorer. And so my mother and I came to Toronto in Canada, and I lived right next door to my aunt, and my aunt's husband was my uncle, and he was at that time flying in England as training people in beam flying. But he was in my life my hero, and he flew airplanes. I wanted to fly airplanes ever since. And I wanted to be an engineer. I wanted to understand the technical side of it and be a pilot, ultimately a test pilot. So that's what it came from. And when I first flew in the Canadian Air Force in training, the very first airplane I flew was a Harvard, we called them, T6. And I'd never been on another airplane ever before. So people say, how did you ever get the bug? Well, it's my uncle. And he was my hero, and so that's the
You
story.
said something I smiled and nodded at, but I'm not sure I understood what you said. Did you say beam flying?
Yeah, that's how they, in Europe, in bombing, how they got so they could do all-weather bombing and so on. They sent beams over the targets or intersecting beams, and they had to learn how to read the equipment and fly the beams.
My goodness.
So he flew an Anson, was a twin-engine trainer in those days, teaching people how to fly the beam. He was
Okay.
a pilot in the Canadian Air Force,
Okay.
Royal Canadian Air Force.
Well, that's what's great about having a podcast is I can learn something every single
Yeah.
episode, just like
Right.
every flight, right? You're always learning something.
Well, as long as you think that way, you will.
Yeah, true. All right, so let's talk about your stint in the Royal Canadian Air Force. Maybe if there was any challenge getting in. I know at least in my life, getting in the Navy wasn't so easy and getting through flight school, but what was that like and what did you end up flying?
So for me, growing up as I did in the center of Toronto, which was in I would say, a working class area, it was safe enough, but you had to know your way around the streets.
Okay.
So I went to school in both public school and high school. Almost 100% of my friends were Jewish. The dominant it was a Jewish population in that area in Toronto. And one of the things for me, to be competitive at school, they believed in working hard at school. I had to work twice as hard to keep up with them. So all through those two things, I worked really hard at school. And I didn't think I was particularly smart, but I outworked everybody. And that's what gave me the incentive, but it gave me the marks in the background when I graduated from high school. In Ontario, there's a grade 13 still in high school. So I had very good marks in that. So then I could apply. I applied and was accepted in engineering physics, which is the honor degree in engineering. And I also applied to the Air Force because my family was not capable of sending me and paying for university. So I got into what's equivalent to ROTC.
Okay.
It's called ROTP. Plan, they accepted me, and I was accepted at Royal Military College in Kingston, but I wanted to be an aeronautical engineer. So they didn't have that course at that time. That's where Billy went. So they allowed me to go to the University of Toronto. So they paid my tuition. They paid me $75 a month, I think, all the books and everything. So that's how I got in the Air Force. But at that time, during the summers, you finish university, we went to pilot training. After a few years, they stopped that. But it was great for me because I went off to, in Ontario and Centralia, flying T6s every summer. And then at the final graduation, I went to the west to Gimli, near Winnipeg, to get my wings on T-33s. There, I was a very good ball player, especially fast-pitch softball. So I was the shortstop on the station team. And when it came time the university then offered me a fellowship to come back and get my master's. So I went to the commander on the base because I knew him, because he knew me, because I played on the station team. And I got an interview with him, and I said, I've been offered this. He said, you got to do that. You'll do that. He picked up the phone, called Ottawa and said, I have this cadet here. I was still a cadet. So I got 9 months off without pay, but I got 9 months to go to Toronto and get that. And I came back and finished up my T-33 training.
Okay.
But because I knew all the people on the base, and when I came back, they said, what do you want to fly? What do you want to get? There were only two things you could do. One was a interceptor, which I didn't like, a clunk it was called, CF-100,
Okay.
or F-86s. So I got F-86s.
Fantastic.
And I went to training in F-86s, then I went to France and flew F-86s for 2.5 years over there. So all we did was air-to-air fight every day.
Oh.
That's
fun, but it's hard on your neck.
Yeah, it's hard on my back. Somebody took an X-ray of my back recently and said, I don't have back problems, but they said, you must have pulled a lot of G's.
How many hours did you end up with in the F-86?
About 600, something like that, yeah. So that's where I learned to fly as a fighter pilot.
Yeah.
And I learned a lot of the lessons that you learn, how to be aggressive and when to be patient. That's tough. It's a tough thing to find the happy medium there.
Sure.
And so I learned a lot. I learned how to be a good wingman, for example. I spent some time getting lectured when we go off on deployments in other countries and somebody get behind us. And in no uncertain terms, as a wingman, I learned that it will never happen again, or else. So
you'll hear about it.
But the most difficult thing I ever had was, qualifying as a four-ship lead.
I bet.
If you climb out, and we had the Mark 6 was the best airplane in Europe at that time, had the most power and so on, and it had slats that worked, and so it was very maneuverable. But if you're leading a four-ship and you see the cons, we always climbed out to 45,000 feet straight out with tanks.
Wow.
And you'd see them coming with the con, and you go, you got to, it's up to you now to say, 3 do this or whatever, and
Right.
you think, couldn't we stop this just for a minute? Well, I think, no, you can't stop. It's 1,000 knots, your closure.
Yeah.
And so I'd have some of the veterans that weren't university graduates had a bit of a chip on their shoulder, and they'd say to me, we're a little surprised you're not making better progress as a four-ship lead. I said, why is that? It's the hardest thing I've ever tried to do. He said, well, with all this education you have, you should be. I said, this has nothing to do with it. So that's a tough world that happens.
Okay.
And jumping ahead a little bit, in the latest movie, Maverick, they capture the air-to-air scene extremely well, how things happen, especially in close, so fast that you can't believe it.
Yeah.
And if it's in too close, you're not going to get out of there.
Yeah. Well, you were, as I understand, in the Royal Canadian Air Force roughly between Korea and Vietnam.
Yes.
And then you went over to, was it the National Research Council for a bit?
It is. It's
Okay.
called the National Aeronautical Establishment.
Okay.
And so, make it a short story, when I came back from Europe,
Mm-hmm.
I met the deputy of the Central Experimental and Proving Establishment, the test establishment in the Canadian Air Force, stationed in Ottawa, headquartered in Ottawa. He came over and asked me what I was going to do when we're disbanding the F-86, and I said, I guess I'm being posted to be a telecom officer. And he said, that's crazy with your background. I'm changing that. So when I finally reported at CP, he had gone, and I didn't realize there was a conflict between the two of them. And the now commander called me in and said, basically, if you're a good boy and work hard for 3 years or so, we might send you to the Empire Test Pilot School. And I'm going 3 years or so, and I still had flying privileges there. So then one of my mentors, one of my idols, a couple of years ahead of me in the Air Force, was now the chief pilot over at NAE, which was taking over its own flying and getting into variable stability helicopters, which they still are world leaders in variable stability helicopters. So he called me and said, why don't you come over and work for us? And given my recent talk with the commander, I said, excellent, I'll do that. And I did it. I literally walked across the street. And it was a good move for me because I was a pilot engineer there where I had responsibilities in both sides.
But before you had gone to any kind of test pilot school?
Correct,
Oh,
yeah.
wow.
And I
is that where
never
you
did go to a test pilot school.
Really?
No, but I was an instructor at all 3 schools in the United States. We had, with Cornell Aerolab, jumping ahead a bit, they invented variable stability airplanes in the early days of fly-by-wire. So they had a modified T-33, but they had 2 B-26s that were used for training. They were the greatest training tool ever in a pilot school, in a test pilot school, because you could change the characteristics. You want to see an unstable airplane? In those days, it was analog.
Oh, wow.
You had all the sensors. You could feed back angle of attack and make the airplane that he's flying. You're watching him, in this case, side by side, but you have a button that you can press at any moment, and you're always attached to the main controls. So he could land the airplane. And every new airplane in the United States, every new fighter for years, was always simulated in the NT-33, the variable stability T-33, beforehand. So I did quite a few. F-18, I did the first. John Paget was the Navy guy that first flew the F-18. He and I spent 2 weeks flying together at Pax River before the first flight. And the same thing with the F-16. So that was the perfect place for me to want to be a test pilot and be a little more involved in the engineering side of things.
Wow.
Yeah.
So you became effectively a test pilot without actually ever going to a formal test pilot school?
Right.
Oh, wow. Is Callsign also where you flew the X-22, I think it's called?
Yes.
Kind of look like a 50-year ago version of what you see now in these Avatar movies with the tilt rotor things running around?
It was built. 2 of them were built by Bell in Niagara Falls. One crashed on their own, but one was designed to be variable stability, a system in it. And ultimately, it was Callsign, the Navy put it at Callsign So we operated as a variable stability airplane and did all the checkouts. So it was four J85 engines and 4 rotating props. So it had 11 gearboxes. It's crazy to think of even trying to fly it
Today.
But you have to remember that in those days we were working for the Navy, and we did a program for them where we designed and flew with two Marine pilots from Pax River, descending from 1,500 feet, decelerating to the hover IFR, simulated IFR.
Okay.
The ducts were automatically moved according to the profile, but that was a long time ago, and those were the kinds of things we did. So,
were the Marines thinking like taking troops ashore, or was the Navy thinking ship-to-ship type stuff?
it was all the early days
Okay.
of what, you see V-22s struggled because the Marines are
Mm-hmm.
persistent, that they got that through a very difficult test program. In fact, I
And
was
lengthy.
watching one today. Very distinctive noise.
Yeah.
It is. So
If you saw it on Coronado, it may have been the CMV-22.
could be.
We've had conversations about that one on this show.
Yeah.
All right, so what happens in around 1970 when you decide to roll south of the border there and go talk to the Air National Guard folks? And your mother was an American citizen, right? So you were already...
Yeah, that really happened out of Canada, going to the National Guard, because we were at Canada in Ottawa. Had variable stability airplanes, helicopters. So we had some association with NASA Langley on the East Coast, which was mainly helicopters.
Okay.
So working with them on joint programs, then they asked me if I'd like to come down and work in NASA. It's like being asked if you want to go to the big leagues, So I went to the various authorities, and I tried to get a green card. I applied for a green card to work. It was difficult. But when they looked at the green card application that had my mother was born in Minnesota, they said, we want to hear more about that. Well, ultimately, after some paperwork, I was established that she was a citizen. She moved to Canada when she was 6 years old,
Okay.
but she was still a citizen when I was born. So they said I'm a citizen, as a U.S. citizen, as at birth. And the Canadians said, you're not deciding anything, you were just born, so it didn't affect that.
Okay.
So I then went to Langley for a year, moved down there, and then I got offered a job in Buffalo, New York, which suited my personal life as well. But while I was at Langley is when I got in the Marine Corps. One of the pilots that I worked with was a Marine in the reserves. So now I move from Langley to Callsign, what was called Cornell Aeronautical Laboratory at that time. And that's where the same thing happened again. They were looking for pilots at the Air National Guard at Niagara Falls, so I went up and interviewed. But now I was already in the Marine Corps Reserve. So I transferred from the Marine Corps Reserve to the United States Air Force, but in the Air National Guard.
So Royal Canadian Air Force to the Marine Corps to the Air National Guard, which is, can we call it just Air Force? All right.
Well, it is a part of the Air Force. It can be activated anytime. And so I flew there 24 years.
24 years, yeah. Retired as a lieutenant colonel?
Right. I was a group commander when I retired, and I was F-16 squadron commander before that.
And what all did you fly while you were there? I thought I read T-33, or maybe that was earlier.
Well, I started with the T-33 because they said they were still flying F-100, so I got a couple of flights in F-100.
Okay.
And, of course, winter was coming anyway, so they didn't want to do a checkout during the winter. Couldn't do that.
All right.
Couldn't accomplish that.
Yeah.
So during that winter, they switched to 101s.
Voodoo.
So the Voodoos.
Okay.
So now I checked out in the Voodoo. I could do that locally. And I flew the Voodoo for a better part of 10 years.
Wow.
And then I flew F-4Cs and then F-4Ds and then ultimately F-16s. We got the interceptor version of the F-16.
Wow.
And the first 12 years of that I was working in Buffalo. And then the last half I worked at Edwards. My boss, Tom McMurtry, who's passed away now, but was honored by the man that took all the pictures for Maverick, because he said when Tom retired from NASA, he flew for Clay Lacy, the photo business.
Okay.
And K2 is the man's name that runs that company. Still does all the photo work in Hollywood.
Mm-hmm.
He put Tom's picture up. Said, "This man taught me how to run tasks and small teams." And he was a great man, not just because he hired me, but he was. They were all marvelous mentors because they had no egos, but they were done great things. I mean,
Sure.
I sat at Neil Armstrong's desk.
Wow.
He was previously in that same office.
So hold on, though. So for the 24 years you were at the Buffalo Air National Guard or Niagara Falls,
Right.
You were able to double dip or do something else besides? Was it like a part-time thing, or?
No, I worked. Well, I could.
Or you took a break and went over and did something else? I'm just trying to understand.
No, I worked at Cornell Aerolab as a regular job,
Mm-hmm.
and I did weekends and
Okay.
et cetera at the Guard. But I also held alert overnight at
Oh,
the
wow.
Guards because we had an alert commitment. So I would go to work. And 5 o'clock, I'd start alert and get off at 8 o'clock in the morning. And so that, for 12 years, I did that. And then the reason I started talking about NASA was the man that hired me, Tom McMurtry, was now the chief pilot. So he said, "We want you to stay in the Guard." So I said, "Well, that's in Niagara Falls. We'll figure that out." So he would often come to me and say, "Do we have a contract right now with Callsign or Cornell Aerolab?" And first I said, "No, I don't think we do." "You sure?" So I would occasionally go on a Guard weekend and get an airplane to go cross country, but not always. But I learned how to sleep on airplanes.
Yeah.
So I had
Not when you're
cooperation.
piloting them.
Yeah, right. So I had help at both ends
Okay.
that wanted me to do that. So I'd come to the Guard. I'd literally fly overnight, go to Chicago. I'd sleep all the time, and then I'd go to the Guard in the morning. I'd fly twice that day, and when I left, but I'd get 5, 6 days at a time there. And when I left, I would fly twice and then go and pick the 5 o'clock flight back to L.A. I did that for 12 years. So
Were you married?
yes, it's still at the end of it too.
Still at the end, yeah.
Yeah,
there you go.
right. That's good.
Oh, my
Yeah.
goodness. Wow.
No, I had and all those stops along the way taught me a lot of lessons.
I'll bet.
And the reason I got the job at NASA was because of the Guard flight at Edwards. It's because I had, a high-speed time now. Lots of my logbook looked good,
Yeah.
so that allowed me to get the job.
Oh.
And when I was chief pilot at Callsign, Cornell Aerolab at the time, I told my buddies at the Guard, "I'm going to take this job at Edwards." And they said, "Are you crazy? You're going to be Blue 4 out there, the new guy." I said, "I don't care. That's my dream. You get back to the beginning. The dream of any test pilot is to be at Edwards, not Pax River, but doing testing at Edwards with, all that 20,000 square miles, rather, to fly in and sunshine most of the time. Lots of wind, but
But nobody decided, hold on, this guy's never been through test pilot school. I mean, you were essentially just kind of
because I had learned
grandfathered,
it at in Canada at the National Aeronautical Establishment. I had learned testing in the variable stability airplanes and running my own projects and flying them and safety pilot, and then I had learned a lot elsewhere. So my experience then counted. And now, like where I've worked the last 10 years in the world of UAVs, testing at Grey Butte for working for a small company for doing all the testing for the MQ-9 for the Air Force under the auspices of Edwards. So they now have inserted, because they came up with something, you have to be a test pilot graduate in order to fulfill the slot for test pilots. So then they said, or be 10 years experience, 10 years a member of Society of Experimental Test Pilots. Well, I have been 50 plus years a member of that, and I was allowed to be designated a test pilot.
Wow. Edwards in the 80s and 90s, that must have been pretty fun, impressive. I don't know. There's a lot of interesting things in pictures on the flight line.
No, it was a great opportunity and made possible by the people that were there, like Tom McMurtry and Bill Dana, who both passed on. But when I was introduced to the office, I stood in the doorway with Tom McMurtry, and he pointed over to this desk and said, "Bill Dana, who flew the last flight in the X-15, was sitting there at the other desk that were butted together. And it turns out the empty desk that I was going to have was Neil Armstrong's desk when he worked there. He worked in the same office.
Wow.
So that's the kind of people I was introduced to. And I say it in every talk that I give, what Bill Dana's advice to myself and another test pilot that came a year later from the Navy, Ed Schneider. He said, I'm not going to give you a lot of advice here. I'll give you just one piece of advice that you're working here. Always take your job seriously. Never take yourself seriously. Meaning, control your ego.
Mm.
And that's the way he conducted himself and all of them. And so they're pretty serious about doing the job right. If you didn't do it right, you're going to hear about it and learn about it. But if you took yourself seriously, they'd fix that in a hurry.
Yeah.
So that was my luck, following my dream to work with people, mentors like that.
Yeah.
And so I could combine the two, more the test flying and the test piloting at Edwards, a little bit of engineering, so.
You mentioned Top Gun Maverick earlier, and the movie begins after the little carrier scene, ostensibly with a test piloting type scene, although I think it's supposed to be China Lake, but very similar. And it has sort of a, dare I say, cavalier, of course he's Maverick, right, approach to, we'll just go Mach 10. I mean, right, Hollywood doesn't always get it right, but in the 80s and 90s, was it just, let's take an airplane and go see what it can do, or is it very much,
No.
Right, we have something to do today, how are we going to approach it and go do it safely?
It was very disciplined, and that's why you take your job seriously.
Mm.
I didn't realize how important it was until later in life that I was in an environment, too, where I could raise my hand and ask a question or point out a problem at any time, anywhere, not be sort of, you just sit down and be quiet here, we got to do this. So I did have somebody when I got to be flight ops talking to headquarters NASA, and this guy was asking me about some schedule, why did we put so many weeks in it or whatever. And I said to him, well, that's because, we're doing flight research, and we don't know all the answers, otherwise we wouldn't be doing research.
Yeah.
So he said, yeah, well, I've heard all that. I've heard all that stuff before, but can't you tell me next year how many discoveries you're going to make? And you go, I don't think you understand that flight research is a discovery process. That's why we're doing it. But they don't. So that's why it's so important. The bottom line to me, at any time I get the opportunity, is to be able to communicate. And you need to learn as a tester, not just a test pilot or anyone, to be able to speak up properly, not in a cavalier fashion, and not have your head chopped off. Because the initial reaction with the people that tend to run the money is get rid of this guy because he's hurting the schedule. Well, another great test pilot, I put these takeaways in my talk. If you think safety is expensive, try an accident. Well, that's the trade-off.
Yeah.
So anyway, that's my theme of the moment.
Sure. Yeah.
But historically, it was not cavalier. But it was, we had a squash court for the pilots. We had a great job. They wanted you to be proficient. I mean, they would talk to me and say, hey, you need to fly more. You need to fly a little bit more, because that's a safety issue. You want to be proficient, not just current. So that was a great opportunity, greater than I anticipated at the time or felt at the time, but later on I realized what a marvelous opportunity it was.
I had a boss once tell me he thought I was flying too much. That wasn't fun because we were on deployment, and I'll leave it at that. But I don't think I've ever had a boss tell me no, I need to fly more. Raj, can you help me with a memory I'm not sure is true or not? I remember going to an air show at China Lake in the 80s, and I swore I saw the F-20 flying, and I thought I remember hearing that Chuck Yeager was flying it. Would that be possible?
Not likely that Chuck Yeager was flying it.
The F-20?
But it's possible the F-20 was flying.
Right, okay. Yeah. And then I think I remember going to an Edwards show later, and I want to say maybe it was the 40th anniversary of the supersonic first flight. So that would have been late 80s. And you had already said something about Chuck doing that. Would he have flown like an F-15 over Edwards
Yes.
show up high? And...
He traditionally flew after he retired. He would open the show in the back seat or in the front seat,
Okay.
as they chose, but in a two-seater, breaking the sound barrier.
Okay.
Yeah.
Well, I'm kind of disappointed actually to hear the first part because I'm writing my memoirs right now because people want to know my story from this podcast. And I put in there that it was Yeager flying the F-20 and then later on this other thing. So I'll either have to let the story be more fun than the facts, or I'll have to go back and change it. But
He might
anyway.
have told you he was, but I don't. I doubt it.
I was probably 12 years old, so.
Yeah.
But I do remember going out to Edwards, and I walked away with like these little one-pager pictures of this airplane that looked almost like an F-5, but with the wings going the wrong direction. There was a picture of a 747 with a space shuttle on top. I mean, gosh, like I said earlier, I think that was just seemed to me like the heyday of really amazing things happening out there. But maybe that was the 40s and 50s. I don't know.
Well, there were amazing things happening, and those demonstrators you just talked about, X-29 and the X-31, all flew out of NASA. They didn't fly the whole flight, but the majority of all the test flying was done at NASA. But it was a joint Navy, Air Force, whatever, German in the case of the X-31. So, and then the SR came back. It had been there for like 10 years.
Right.
It was kind of a YF-12 actually, but they flew it looking at aerodynamic heating and the beginnings of digital fly-by-wire. Eventually, the SR was converted to digital, the flight control system, but they were clever enough not to mess with it. They virtually duplicated it, didn't go and have to retest things too much. So it improved the range by about 7%. Because they could control the inlets very much more accurately. Yeah.
How many came back? Because you sent me a PowerPoint presentation that I was able to watch before this discussion today, and it's got embedded videos, and I see you flying, which is fun. But it was the one with like the little piggyback canopy on top.
When I was there, we got 3 airplanes.
Wow.
We got 2 A models and a B model, and that's when the Air Force retired the SR the first time in the 91. They had decided to. It was a SAC was running that. That
Strategic Air Command.
They needed money. They wanted money for other projects, I guess. But
okay.
They retired it, but then they brought it back, and they actually reconstituted the debt at Edwards. So we got 3 airplanes. But the B model, when the Defense Department agreed to give 3 to NASA, the B model was in pieces in its big inspections that happen, I don't know, every 10 years or whatever, at Palmdale. So then I actually saw the memo written by Cheney directing them to get the B model back together and flying to deliver to NASA.
Oh, wow.
But that's the B model. The B model was a cockpit that you could fly from in the back.
Okay.
But the canopy was what sat above. They put an additional canopy that, with the spacesuit helmet on, you could fit in there. You'd look out, you could fit in there. But if there was an on-start, which occasionally happened, you'd actually bang your head against the wall.
What was it like? Actually, is the way I want to ask this. When it seemed that this aircraft was coming back and you would have a chance to fly it. I mean, I have to think, of course, you've had some amazing experiences by this point, but was that a pinch me moment or was it just, okay?
It was an unexpected moment.
Yeah.
And of course, I was assigned 2 pilots to each project. So Steve Ishmael had been there a while, a lot longer than I had, and myself were assigned as the SR pilots. That was a real plum in the office. For me, and I certainly appreciated that.
Yeah.
And the same man that hired me was the one making those decisions. So yeah, it was a big deal. And we had a chance, the people that were going to fly, to go the simulator that was at Beale, and Rod Dykman was the squadron commander at that time at Beale. They were starting to wind down now. Well, he works for American Airlines. He had left when they disbanded the SR and joined American. And so anyway, he, though, his last thing in the Air Force, went to the Binghamton, I think it was, in New York to accept the modified simulator. The simulator was brought up to date, and it was really an excellent simulator with visual and small motion, separated cockpits in the back seat, or you could fly just with an instructor behind you. And so he was there and met us, and then he ultimately was working for American. When we got the B model, when we were ready to start flying, he wrote NASA and volunteered. He said, I'll take time off from American 3 weeks, and I'll come and check out Steve, the first guy.
Okay.
And he did that, and he annotated every page of the -1 with hand notes. This is really important. Forget about this.
And the -1 is the manual.
The manual, I'm
right.
sorry, the
Yeah,
flight
that's right.
manual, yeah. And he did all that. He flew, I didn't fly with him. Maybe I flew in the simulator with him, but he flew with Steve and checked him out. And then I made the first flight, my first flight with Steve Ishmael, which we had a non-start.
On the first flight.
On the first flight.
Oh, gosh.
It scared the crap out of us.
Raj, I don't know if this is an easy way to quantify, but let's say at some point in your day at work, you say, okay, I need to start studying to learn to fly the SR-71. So if you imagine you start the clock there, how long does it take before you actually get into an SR-71 and go fly?
Yeah, I think a month. Like
a month?
We had a simulator and so on.
So you could study the systems, learn the procedures, start up and shut down in emergencies, get in the simulator a whole bunch, and a month later you could go fly.
Yeah, maybe 2 months. I don't know. Yeah, a month to 2 months.
Wow.
Not long.
But of course, you're not a brand new pilot.
No. You're right. But they made sure that you were ready.
Right.
You know, but they didn't send you to class exactly the same as you might in a new guy.
Right.
Yeah.
Wow. And so how many hours or flights or what?
I flew 8 years.
Wow.
But we didn't fly a lot. I flew 150 hours roughly
In the SR-71?
in that time.
Okay.
Yeah. So we also, when the Air Force reactivated the program at Edwards, myself, by this time, Steve Ishmael had left, that flying the SR, and Ed Schneider took over, and I was the prime pilot. And so then we worked with the Air Force, reconstituted the program, but they had no instructors in 94, 95 time period. So they came and annotated. They anointed you. You're an instructor pilot. I was we were official instructor pilots for the Air Force. So the first guy I flew with had 900 hours, but he hadn't flown for like 8 years.
Okay.
So, and I'd keep asking him, what'd you just say? Because I'd take notes. I was taking notes. So we had a good relationship. They then flew the B model.
Okay.
And they then got an A model.
Right.
The second A model that we had, they started flying.
But right, I mean, all these aircraft, where were they in all that time? In some sort of level 1,000, I think you call it, preservation somewhere, or?
Yeah, we had the two A models sitting in our ramp, but we flew the A model and the B model.
Right.
Regularly.
But when the Air Force was getting back into it, were they going to bring some out of?
We had a crew that were proficient at maintenance on the SR.
Okay.
We were cleared to fly it then, and we flew it to Palmdale, and they re-inspected the airplane thoroughly and then turned it back to the Air Force. Likely we flew it back and landed it, and they took it over. Yeah.
Okay. And NASA's role in this, was it also partly for, I think you had said you did some research, was it this,
they did a lot of research for there was quite a lot of, for several years, idea to take a vehicle, take it off and fly it to space. And then it sort of impractical you could have thought about it beforehand, that the amount of fuel you have to carry and the size you have to. So that was part of the doing data flights for that. We did some oddball data flights for people simulating a satellite going by, because our going at Mach 3.2 across, Phoenix is like some of these satellite things. It's like a satellite going by. So we checked out some systems like that. And then the laser was a new type of rocket engine that had never been flown. If you look at pictures of space planes and see them, you look at like the exhaust looks like a rectangle.
Okay. Uh-huh.
It's got slices. Each one of those slices could be a laser, a rocket engine with its. The thing about a laser was it only had one side of the nozzle. The other side was the air at the Mach number you're at. It's self-compensating.
You're saying the word laser. Are we thinking like a no kidding light laser?
No,
like
I'm sorry, that's an acronym.
Okay.
It's Linear Aerospike Rocket Engine.
Okay.
Sorry.
No, that's all right.
And we flew, we tried to fly for several years. We had Lockheed Skunkworks make a 1,500-pound canoe, if you like, that sat attached to the top of the SR, blanked out the drag chute, for example. But it carried the tanks for gaseous hydrogen and liquid oxygen, and we had a 10th scale model of one slice of a laser mounted on a fin in between the two tails. And the idea was we were going to do a 7-second burn to demonstrate for the first time in flight a laser actually ignited. So we had that done at the Skunkworks. At the time, the head of NASA was championing this better, faster, cheaper thing, which you can't have all of them.
That's right.
And so they didn't use the valves that were the latest and most expensive ones. So we got the airplane, and then it was leaking. You can identify oxygen leaks pretty easily. At least they have sensors that can do that.
Mm-hmm.
Hydrogen's tough, because it's just a tiny atom, And so we did a lot of work trying to get the leaks down, and we kind of succeeded in that in the oxygen side. But you can't do it with the hydrogen. There were no sensors to do that. And we went through many safety boards, and we had people on the boards, or not on the board, but you talk to people about rockets, and they come from Huntsville, and they're used to something goes wrong, they blow it up or something. And one guy said to me once when we were debating something about this, and he said, well, what's the big deal? At the worst case, it can be just a small hydrogen fire. I don't think those two words go together. Plus, we're 20 feet ahead of where that fire is, and you can't just press a button. So ultimately, the safety board, the director retired, and he might have had a different view. The crew was convinced that the risk was not great for 7-second burn and so on, of having simultaneous leaks right together.
Yeah.
But we never got clearance, so we failed. That's the only time we ever failed in a project.
Oh, wow.
Yeah, we failed in the laser. Yeah, didn't fly it.
We had a whole episode.
We flew it, but
you flew it, but
we
not
never
the way you
ignited it.
Yeah. We had a whole episode on the SR-71 with Brian Shull, who actually passed away recently.
Yes.
And he was quick to give credit to Kelly Johnson and the team and all the folks that made that aircraft happen. But he liked to relate it, as I recall, to like a 57 Chevy. And it's just pure and plain and not a lot of thrill or frills maybe. But I want to ask you, when it was starting to come back, now we are here, in the 90s, I believe. Was there an urge, or maybe there was an actual effort to, we can upgrade the cockpit, or we can fill in these leaks, or we can change the fuel? Because I think the JP, was it 8? Yeah. Was a challenge. So when it came back, were there people that were championing that, or was it just, no, take it as it is because it's too much money to try to do anything else?
Yeah, well, they did go through the business of changing the flight controls to digital.
Okay.
Not just the flight controls, but then inlet controls. And that was a big effort.
Okay.
But he just recently passed away, and when I asked the SR people, I never met him, but they look at me and say he was a great storyteller. But you think of, if you see, there's on YouTube, there's an 18-minute video called the insane engineering of the SR-71. It's animated, it's terrific, it's really well done. But you think of that engine, how it functions, you would not think of 57 Chevs.
Yeah.
It is an amazing accomplishment to be a turbo ramjet, and that's the spike moved 26 inches.
Mm-hmm.
And yes, you had to be That's 26 inches in an environment where the temperatures were like 600 degrees or higher
Celsius.
in the inlet.
Yeah.
And the impact temperatures, that's what kept, that's what limited the speed,
Yeah.
was temperature. So nowadays we have new materials. So when you talk about doing some things at high speed, you have materials that can, it's not easy, but
Yeah.
it's not outlandish with the materials we have. But the SR, that's why it had titanium structure,
Right.
because at 3.2 Mach, aluminum would melt.
Yeah. And they had to invent the tooling to make the aircraft
yeah.
out of all that.
That's-
They have one of those engines at the San Diego Air and Space?
No, I think I heard that.
Yeah, it's downstairs. Our videographer, Kevin, over here, and I got a chance to see it when we were talking to them about the episode that we did with them. So
But,
it was
you know,
neat. It was huge.
Yeah, and the fuel is a coolant. It goes through the whole airplane.
Mhm.
So I don't think that's a good description of it. But it functioned. It didn't have a lot of. There were some problems. We had one that we had an emergency at Oshkosh, refueling over the lake that I was involved in. The nozzles were the pressure in the nozzle, the medium that was in it wasn't hydraulic fluid, it was fuel. So what happened was one of the lines, there was a small little pump that changed it to 3,000 psi. And one of that got out of balance and it cracked the small line that went to the nozzle.
Oh, gosh.
So then it was spewing fuel right throughout out the nozzle. And we were very close to coming back to Edwards. We were over the lake, and I had told one of our guys that was taking an F-18 there to be on static display, why don't you fly with us? Give you something to do as well.
Mm-hmm.
And it was good that he did, because it was a tanker from Edwards. They knew us, and but the tanker guy kept saying, there's a lot of stuff coming out your left exhaust. And we were getting clearances. The guy in the back was talking to clearances, and we were going to fly by supersonic, high up, but we were going to transition right over Oshkosh. And so then I said, come on, why don't you come over this side and have a look? Tell me what you see.
Mm-hmm.
So he got over there and he said, boy, there's a lot of something coming out of the left nozzle. It was fuel. It was pouring. If we'd lit the afterburner, I'm sure bad things would have happened.
Wow.
So we declared an emergency and had to dump 60,000 pounds of gas over the lake. And and then we landed, and I'm talking at the backseater was going, oh, don't shut the engine down. And I'm saying, well, the checklist says, I said, okay, we're going to shut it down at 15,000 feet coming down. So we did. So we're straight in, shut it on one engine. And then I said to the tower, the chase is going to land in front of us and clear the runway. So
Is this in Oshkosh? You're landing there?
No, we're
Okay.
we're landing in Milwaukee.
Oh,
Sorry.
all right.
So we declared an emergency and we went into Milwaukee.
Okay.
And so he said, I don't know what you said, but you're clear to do anything you want. So we did that and we landed okay.
All
But
right.
the tanker also landed, and our crew chief was in there. And after we got out of the suits, they opened the panel, and this line was broken at both ends now. So we were lucky that it
But
didn't.
if you just land in a place that's not expecting you, like Milwaukee, you're dressed like an astronaut. Can you get yourself out of that, or
No.
you just
Yeah,
sit in
you
it
need
until
help. Yeah.
until someone comes to help you?
Well, the back seater had the pins. We have to pin the gear before we shut the engine down.
Oh,
That's just in case there's some
protocol.
That's
Wow.
protocol. Yeah,
Yeah,
that's
yeah.
the checklist. So he had the pins. So he had to get out, and the fireman had a ladder off the back end. So I'm watching him, but the first thing he has to do is get out of his suit. Then he's in his long underwear, and so the long underwear is modified so it takes care of all that you need to take with you.
Mhm.
And that you can imagine that you have a little bottle in your leg and how it gets there. But so I'm looking at him, and he's getting out of the suit. A lady happened to be helping him, and the guard and reserve is there, so they were a great help.
Oh, good.
So he gets his suit off, and now he's holding the pins in one hand. He's holding his underwear across the hole in the front, and he's walking, and there's a puddle of fuel around the airplane.
Ooh.
And he's in his stocking feet, and I'm looking at him. I wonder how he's going to do this. Well, he went back and got his boots on, but he had to trump through this gas and put that in. So that was the amusing side of what could have been a disaster.
Well, and I appreciate that you just summarized it that way, because one of the things I sometimes ask ask my guests is, this business is very serious, but there's a lot of opportunity for some really great humor.
Oh yeah.
It's
Yeah.
I don't know, paradoxical to me, but I'm glad it is, because
Bill Dana knew that.
oh yeah. Oh, that's right. That
Never
quote,
take yourself
that's a
seriously.
good quote.
Yeah,
Well,
yeah.
yeah, and I don't know if it's just a coping mechanism for the things that we do, or maybe a defense mechanism in some cases, but
Oh, I think so.
yeah.
Like
Yeah.
firemen.
So when you were flying the SR-71, was that all you were flying, or are you flying almost everything?
No, I was flying other things.
Okay.
Yeah.
And you didn't find that difficult to keep straight what you're doing today or tomorrow? I mean, by that point, you have a lot of experience, but...
Yeah, but we were, there was a limit to what you didn't...
Sure.
We had two things. We used checklists, and we made our own checklist, like of a big complex one to get on and off the ground maybe. But we used checklists. We
Right.
didn't depend on memory or anything
Sure.
otherwise, which was because you can't, if you're going to go fly 3 or 4 airplanes, you need to not miss something.
All right.
So that was they monitored that, but that was your job.
Yeah.
You know?
Checklists are great because you don't skip a step, like taking the gust lock off the flight controls. But
Yeah.
also, I have to think, right, with enough experience, you can sense things, right? I don't know, seat of the pants, sixth sense, I don't know what you want to call it, but right, does the airplane talk to you a little bit too, I would think, when you...
Well, I think in general you look around more than you think.
Mhm.
I've been in an F-16. It has hydraulic cages here, where I was flying with the Air Force and dropped a bomb as part of a joint program. And as I turned to come to initial, I saw it. I said, what the hell was I looking down there for? I saw the one gauge was at 0. And you look around a lot more. But, yeah, you got to be disciplined, though.
Yeah.
Yeah.
It probably didn't register every time you looked at it. It was what you expected to see, but maybe you subconsciously
that
looked.
happens a lot.
Yeah, and all of a sudden
You
one
think
needle,
you see it and it's
yeah,
not there.
Yeah, true.
Yeah, so.
And vice versa. Wow. I want to ask you about the X-29, because that's just, again, I had a picture of it on my wall, and it just seemed crazy, but I guess, I don't know, tell me what you can about why and how. And
Well, the
what it was
X-29, there were 2 demonstrators built,
okay.
and there were X-31, there were 2 demonstrators built. So the X-29, Grumman and Long Island, they flew the first 4 flights, and the last 2 of which were, I think, at Edwards. And there are then we took over for DARPA, the Defense Advanced Research Project Agency, does all the way out stuff for the Defense Department.
Mm-hmm.
And they have agents, and in this case, NASA was an agent, and they took on the flight safety responsibility on behalf of DARPA and ran that. So we started flying the airplane. So lots of amusing stories here. I just digress in one. The chief test pilot was flying it. Now, the business about controlling your ego, there are a lot of cases where chief test pilots never figured that out. And likely that was the case here. But so I was a chase in a 104, you know.
Ooh.
So we chased all the data flight, all the test flights. So I knew he was finishing his tests. So I wanted to get out of there because I didn't want to be on the runway when he was coming in or have him to delay. So I leave, and when the other chase is coming, so I get out of there and I land and I park the airplane and I'm walking in, and there's an Air Force colonel that is walking towards me and greets me, and he says, "Did you see the roll?" And I said, "The what?" No, I didn't see anything. Why? What happened was that the test pilot, whose name I won't repeat now, but he did really a flawless, very efficient test points. And he finished those, and you can imagine this is third flight of this very unusual airplane. So the control room is got 20 people in it that are all looking at screens and whatnot, and he does a roll. He doesn't say a word.
An aileron roll.
An aileron roll.
Okay.
Well, that's not been cleared. Mm-hmm. This is not in the envelope, but you can imagine what the heart failure in the control room. They think there's some uncommanded something is broken, and there goes the roll.
Right.
And so that's what he did, and he was removed from the program by the Air Force.
Wow.
Yeah. And then the number 2 guy, who was a close friend of mine, took over, and he flew with us for the next couple of years. But it had a lot of technologies in it. It just didn't. It had an aeroelastically tailored wing. I mean, the Germans built a forward swept wing in the Second World War, but you had to. You can imagine, and I'm holding my hands up on purpose, that as you increase angle of attack, the angle of the flow to the airplane and therefore the lift, what's going to happen to the wings? They're going to bend. And what's happening to the angle of attack locally? It's getting bigger. So it's going to bend more. So there's a point you will reach where it's divergent. Well, you have to put a lot of extra strength in the structure, so that offset some advantages and so on.
Okay.
So they could aeroelastically tailor the wing, that it was built, and they could make the curvature of the wing such that they could delay that divergence. So that had never been done. So first of all, it was an aeroelastic. It was a composite wing. Lots of structural or manufacturing problems that hadn't been solved, because this was brand new. You have to always translate your back. Yeah. And then it had a canard that was most importantly, it was statically unstable. If the airplane didn't have the flight control system, which was 4 channels, or 3 digital and 1 analog, 4 channels, redundancy, that airplane would, at 250 knots, would likely break in half.
Yikes. Because
it's 0.12 seconds to double amplitude. It would double its amplitude. That's how divergent it was, every 0.12 seconds.
Wow.
So that was really unusual.
Yeah.
And then it had a canard in front that was in a different position and so on. So there were about 4 or 5 technologies that were new in that airplane. So it was my opportunity to be involved with a brand new airplane. This was there were 4 flights before we got involved in it. And then we were doing systematic checking and increasing the speed. And they invented in the control room. They had all the information. We could do a frequency sweep in the airplane. That's moving the stick maybe plus or minus an inch, let's say, at really low, slow, and then faster and faster and faster and faster. That gives a variety of frequencies. In 1 minute, the control room had the answer of what the margins in the closed loop of that system, what margins remained. We were allowed to operate at half the margins that an operational aircraft would. But we could see as we got up near transonic speeds, the slope was going to go down to 0. Well, we could see it before got it.
Before you got
so we stopped, and they made some changes in the control system. They had invented that system, because before they flew the airplane, they had some data from beams, buckling beams, not airplanes. So there were a lot of technologies that had to be approached systematically and carefully. And then at the end game, you asked before as we were talking, say, well, why weren't there more airplanes built like that? Because it reduced the maneuvering drag. That you have a consequence of getting lift as you have angle of attack. As you increase it, you have corresponding increases in drag. So as you maneuver, as you turn, you're increasing the lift. You also increase the drag. So the idea was that forward swept wing at the higher speeds would be advantageous in minimizing, not eliminating, but minimizing that drag. And I think it largely did that. But we do the same things now with leading edge that are leading edge leading flaps, trailing flaps that are controlled by a computer that is putting, therefore, the camber of the wing in the proper camber so that we can get the minimum drag. So you can do it other ways.
Yeah. Was the X-29, though, intended to just study that phenomena of forward swept? So they never thought, we're going to build 4 and then maybe we'll build 400 later? Okay.
It was a technology demonstrator.
Gotcha.
As was the X-31.
Okay.
And there's a lot of merit. We're talking about Kelly Johnson, and his motto was test early and often. So you need to test. You don't need to test everything. We got smarter every day with
Sure.
AI and artificial intelligence and so on. But we ought not to get too confident. It's like Billy's paper, and I won't go through it all, that he gave recently.
Billy Flynn, yeah.
Yeah, it was a case where a tester, the leader, wanted certain test points done, and people were saying, "Oh, we don't need to do that. We never go there." Blah, blah, blah. And they did it, and had they not done it, and not seen what they did on an absolutely 3 sigma day on the water was absolutely without a ripple.
They were over an ocean that was smooth.
They were over the Gulf of Mexico. It was
Okay.
absolutely smooth.
Wow.
600 knots at 100 feet.
In a
And the
in
radar-
an airplane?
The radar is an F-16 Block 60.
Okay.
The radar reflections were not there.
There was no
There's no
waves or
waves,
ripples or
yeah.
wow.
And so they had basically some extraneous, or didn't have the appropriate information.
Yikes.
And had they not grasped that things were not right and not done that point, they might have, at 100 feet, gone into the water.
Wow.
Yeah.
Yikes.
So that's the business. There's always a gray area.
Mm-hmm.
Somebody once said about unknown unknowns. And it changes in size, and the confidence now needs to be controlled. Yeah, we have artificial intelligence that can do marvelous things, but are you absolutely sure? We don't have to do as many test points maybe, but you have to do some. Because you're doing things that you never did before, because you have new materials. And so there's still, testers need to be flexible. They can't be bureaucratic like we always did this. Like in my time, I spent 3.5 years on the Eurofighter as a consultant on flight controls, where people were saying, no, this is the way we do the V&V, the verification validation. Yeah, that's the way you did it 5 years ago. Now it's changed. I'm not an expert at it. And the people in charge, in this case the MOD in UK, said, no, that's the way it's in the contract. It has to be done. I said, yeah, but it takes 9 months instead of 3. Didn't matter. Well, it matters. Yeah. Does matter.
Yeah.
So.
Is it changing because technology is changing?
Sure.
Or okay.
Yeah.
Right.
Yeah, but the people that look at cost and schedule, it's important.
Yeah, absolutely.
It is. But they tend to lean on that and say we don't have to do certain things. Well, you have to be really careful. And that's where you have to ask your subject matter experts.
Yeah.
And they didn't come from Harvard Business School.
Raj, let's go to 2000 now in our little journey back in time. You have retired earlier from the Air National Guard after 20, I think you said 4 years.
Yeah.
You're spending, I think, 18 at NASA, and you quote unquote retire, but you don't really, right? What do you do after that?
No, after that, I, because of my X-31 connections, I guess, experience, they asked me to come over to the Eurofighter. And Germans, it's a four-nation thing, so the Germans were responsible for flight control design. So I went as a consultant to the flight joint team, it was called, 4 nations. That's Britain, Spain, Germany, and Italy, which is unique, all different cultures. So I was allowed to go to the ops meetings of all the pilots and so on. But it was challenging for lots of reasons, different cultures. But when I first went there, I flew the simulator, and it was early on. They hadn't finished it all, but they said, what do you think? And I said, do you want me to tell you what I actually think? Yeah. Yes.
Can I interrupt? Is this a simulator like I, as a regular pilot, might go get in? Because you have fancy...
No. It was it was a simulator of the Eurofighter as it stood at that time. So the display wasn't...
But there are, correct me if I'm wrong, right? Fancy, like engineering style simulators that are super close.
Very
sorry.
exotic
Didn't mean to
simulator.
interrupt the story.
No, it's fine.
All right, so they asked you
So
what you thought?
they asked me, and I said, I think it's like an agile Airbus.
Oh, ouch.
It's not a fighter. I mean, its response characteristics flew very well, but it's not a fight. It doesn't have the response rates and so on. So they were like not too happy with that. But I'm not putting myself to say that I changed it all, but during the time I was there, we gradually got special teams, multinational, to work on specific problems and use the airplanes as we could best use them, as because I used to, and Billy used it in his talk actually. I didn't, somebody else said it and I remembered it, but I used to tell him, come on, we can put those fillets on the leading edge of the wings here on the real airplane, on the prototype. We have 7 of them, and we can fly it up to the conditions in the restricted airspace, in already cleared airspace.
Mm-hmm.
Now we can do the tests in God's wind tunnel.
Which
said,
is probably
what do you mean
better.
God's
Mm-hmm.
wind tunnel? Well, it's got a perfect visibility. It's got perfect feeling, all the G-forces, all the rates, they're all right.
Yeah.
There's no question about that. But they were stuck in their ways. They wanted to go to the wind tunnel. It would take 6 months to go to the wind tunnel.
Oh, gosh.
They could use the real airplane as a wind tunnel.
Hmm.
So some enlightened people, Kelly Johnson is way, way ahead of his time, was aware that a small group of talented people that were somewhat relieved of all the bureaucratic structure of the big company
Mm-hmm.
could do great things rapidly. When you think of it, 59, the design of the A11, A12, whatever you want, the first version, 3 years later it flew. 3 years. Nowadays, you might be talking about 10 times that.
Yeah.
Now, it's more complicated, but still, he wanted to test early and often, and that's the basis of doing developments rapidly. You have to be able to do that. Do you take more risk? Well, you shouldn't take ridiculous risks, but you like to do what you're taking it incrementally.
Right.
And so that's, ask me what I do now, that's what I preach. Yeah.
You used your expertise to probably mentor and counsel or talk, or you've gone on the circuit a little bit, yeah?
I try to do that. I did, for example, with Billy, is affiliated with, part of, he's vice president, he says he isn't, but he's at technical development, head of technical development for the International Test Pilot School in Canada, in London, Ontario.
Right.
So they had a major meeting for the Society of Flight Test Engineers in January. So he said he arranged it for me, but that's all right.
Yeah.
I was the luncheon speaker, and the theme was, what's the future of testing? Well, that's a very broad thing, but fundamentally it would be that technology is changing more rapidly than we can imagine, but the people, now they're somewhat replaced with AI in some situations, but the people and how they lead or how they work together as teams is still there. They still have to work together and be effective. So they have to learn how to do that, or at least control their ego and build bridges. That's the bottom line.
There you go.
Yes.
Yeah, good. Well, and you also did a stint as the president, right, of the Society of Experimental Test Pilots?
Yeah,
SIP?
in 96, a long time ago.
Okay.
I was the president, yeah.
You still go?
Billy
I'm
was the
guessing.
president. So
All right.
Canada is, people from Canada have been presidents of that society way out of proportion to
Oh, yeah.
the populations.
Huh.
So
Speaking of Canada, aren't you also a member of the Canadian Aviation Hall of Fame?
I am, yes, yeah, 2017.
Congratulations. Wow, that's fantastic.
So man that we knew that was a Canadian test pilot, who's now like 94, I guess, lives in Vancouver. He's the one that spearheaded that, and he's spearheaded trying to get Billy in. Previously, the Hall of Fame was in northern Saskatchewan somewhere, way up north. Typically, it was only what you did in Canada, so it was all like bush pilots and so on. He got it extended to include whatever you've done internationally. So, yes.
All right, Rogers. I have some questions here I want to ask you from our listeners, but before we do, I just had an epiphany. I want to see how many fighters I can get through, at least in America, and it's going to be a lightning round. You just tell me yes or no when I say it. Are you ready?
Okay.
So I don't think there's an F1, 2, or 3, although we could debate maybe F1s. But so you said F4, so we're going to say yes. F5?
Yes.
And I'm talking now actually piloting the aircraft. You don't have to be alone, but you did have to control the aircraft.
Yeah.
All right. F8?
Yes. Yeah. By myself, yes.
Oh, really?
No,
All
the
right,
digital first airplane to fly with a digital flight control system
Oh, wow.
was an F-8,
Okay.
digital fly-by-wire at NASA. When I first got to NASA, it was on its last project, and I got to be one of the pilots on it.
Wow.
So just a quick one. I went out with my chief pilot before my first flight. It had to be alone, and he said, "I want you to look at the tail here. Do you see the ventral fin there? Do you see how far it is from the ground? It's about this far from the ground." He said, "Don't ever forget that picture, and don't ever flare this airplane." So that's why they had the wing that went up.
Yeah. The angle of incidence changed, as I understand.
Yes.
One of the only.
Yeah.
All right, let's see. Where did I leave off? F-8.
Eight.
I can't think of anything between that and the F-14.
F-14, I flew by myself. Yeah.
Yeah. Well, with a Rio, I'm guessing.
Nope.
Or, nobody in the backseat?
No, it's because we had the test airplane from Grumman's test airplane.
Okay.
Came out to NASA, came out to Dryden when they needed to do special
Oh, wow.
tests, and they had one with digital fly-by-wire, the first version of that. They had some problem with the wing sweep. They had one that was asymmetric, so they would bring them out, and usually they'd operate out of Dryden. So now they had this special test airplane. I forgot the number of it, but it's the one they used all the time. But the back seat was full of instrumentation.
Oh, wow.
So I'd ask my guys that flew it all the time out there when it was out there, and I'd say, when we climb out at 250 knots, we can pull full back stick. How fast can you pull it back? They always did that as a routine. You pull full back stick, the airplane, this huge airplane, goes like this, and then it goes back down. So they would say, "Oh, fast as you want." "How long can I keep it there?" "Well, as long as you want." They're all sort of casual about it. But anyway, I did by myself.
Okay.
Yeah.
So I know you flew the F-15, and we didn't barely even get to scratch the surface on that. Definitely the 16. I guess probably not the. Well, you tell me. Why F-17?
I did the simulations of
Oh, wow.
it. Yeah.
Okay.
Yeah.
F-18.
The F-18 I have like 1,100 hours on
Oh, wow.
F-18.
And so now I'm going to sidebar the conversation a moment. You talked earlier about thrust vectoring, and there were some aircraft, F-18, F-16, that had some thrust vectoring test. And I guess I want to ask the rookie question, which is, why can't I just, for example, now with the Super Hornet, if I'm the Navy, why can't I just come to you or Boeing, hey, I want thrust vectoring?
Well, theoretically it could, because people solved various ways of doing it. In the X-31 it was with external paddles, but later on they did the whole nozzle.
Right.
So you could do the nozzle round. So Pratt & Whitney had that. So that the technology is, and on the F-16 that's what they put on. So they could do that.
Really?
Yeah.
Does it just come down to money?
Sure. Well, it's a lot of development.
Yeah.
Now the F-22 has pitch. So that's why the F-22 can go to really large angles of attack.
Yeah.
Because the aerodynamics have gone. When you're that slow, you don't have enough aerodynamic control. But with thrust vectoring, that's why the SR-71 could fly stabilized at 70 degrees angle of attack.
Wow.
So, and from the fighter pilot point of view, we did all the X-31, the graduation exercise for the X-31. First of all, there were only 2 people that flew the X-31 with us, and we had a chase. We flew 1v1 with an F-18 with a centerline tank. That was a standard that we flew against. We only had 2 people, because this is air-to-air inside, like 500-foot bubbles.
Okay.
So inside, we had only a couple of people could fly the F-18. They were all checked out in the F-18, but that wasn't a thing you came in the morning and said, I'll take that seat. So we restricted that. Ed Schneider and one other person was, and the Freddie Knox from the contractor could fly the X-31, but we flew against every fighter, F-14, F-15, F-16, 1v1, with orchestrated to the extent we started one at 250 knots line abreast, and the other one was 350 knots line abreast. So I just regress to say I can tell you the story of one day that I died, but I didn't. But I know how many of my friends died. So I'm with my buddy who's in the F-18. I'm in the X-31. So it doesn't matter what speed we were at that particular time, but our job was to air to see who's got the advantage. So thrust vectoring has a great advantage at low speed, but it goes back to the basics that I said, aggression and patience. It's a different equation with thrust vectoring. So you can do some phenomenal maneuvers with thrust vectoring. You could go up and turn around and so on, but your opponent is going to be watching you do this and clapping, but you're up there as a constant target and he's shooting you down.
Uh-huh.
So just like any air-to-air thing, you have to drive the fight. And so he has to be responding to you.
Mm.
You do some fancy maneuvering with thrust vectoring, you're going to die. But if you use it to drive the fight, and I had to tell my very talented young German guy who came to be the pilot from the German side, and after he lost, which I enjoyed because I beat him in the F-18, I told him the secret: do not make independent thrust vectoring moves because you have huge drag penalties.
Mm.
But we would always have the fight at the end when we'd win. We'd always win with these guys, but you'd be in the center going down like a rock,
Mm-hmm.
both of you, but he is going around in a circle and you're in the center of the circle now just yawing around with him with a pipper on him just pointing at him because you can do it with the thrust vectoring.
Uh-huh.
So we've had, admirals and so watch that. What the hell's the matter with that guy? Why doesn't he take it up? He has no energy left. He's just pulling around the corner and he's dead.
Mm.
So when I died, though, I was a lot of time in air-to-air, Ed not so much. But you never thought of this situation quite. But I want to win, so we take it up, I don't know, 45 degrees or something, initially, right away. But I take it up and into him because I'm going to roll across him.
Mm-hmm.
And I say because I'm anticipating that I have the high. I'm high.
Right. You call
I'm
the
high.
pass.
I'm high. I got it. You can't come high. So I got it, and I started rolling, knowing I've got the high, and I've got him because now he can't keep coming, but he did. When I said, because it's a little confusing when you think of it, change the whole perspective to here, 45 degrees up, what's high? It could be a little confusing. Wasn't to me in there, but now I'm crossing. I got a crossing angle because I want it, but he's still coming. Now, if I was really calculating, I'd say I need to push. We both need to push, but that's totally an unnatural action. So now the crossing angles are such that the closure rate is enormous suddenly, and you can't do anything about it. You're thinking, holy shit, we're going to hit. And so I'm upside down, and I actually crunched down in the cockpit and said,
Here it comes.
Yeah, this is it. And so we went by close enough that I could feel the bump of his airflow.
Mm-hmm.
He could feel mine. But we went with me having the advantage a little bit, so our tails were not crossing. Anyway,
Wow.
we had an ACMI range there, effectively with our radar. So that data went back to Germany, and it was digested there. And so about 3 weeks later, one of the Germans, they were with us all the time, came to me and said, do you know what? And we acknowledged that we screwed up, and we talked about it on the ground. We didn't hide it or anything.
Right.
And reviewed the calls we're going to make and so on. And he said, do you know how close you came on that? I said, no, 25 feet. So that's what's happened to a lot of my friends, and especially in F-86 days.
Mm-hmm.
They had mid-airs, and you go, how the hell did that happen? Well, once you get inside, that's why Maverick captures the rates. They're all F-18s, really, but captures the rates. And if they get beyond a certain point, it's too fast. You can't do anything about it. So we didn't broadcast that story, but we didn't hide it either.
Yeah.
But that was a lucky day for me.
That sounds like it. Golly.
So
Yikes.
anyway.
All right. Let's see. We were F-18 for sure. You said 1,100 hours. How about F-20?
No.
Okay.
No.
F-22?
No, but I knew about it. I was on.
It was,
I was-
yeah, okay.
I was on
F-35
Teams.
was much later. All right, let's see. I got to jump way up into the numbers. What comes? F-86, clearly.
Yeah.
F-100, you said yes?
Yes.
101,
Yes.
102,
No.
104.
Yes. A lot of time. in
Okay,
104.
and you got it on your hat there, I think.
Yeah. Right.
Okay. 105?
No, but I first saw 105 in Bitburg, Germany, when I was in the Canadian Air Force.
Okay.
Took a 4-ship in. The leader was like 19 years old at that time. So we had these, sometimes the paint jobs, the camouflage got a little raggedy. So we came in, and anyway, I would shorten it up. I'm talking to the Air Force people. It was a 105 on the ramp around the corner. And I said, come on, can I go down and see the 105? And he finally says, sure, yeah, I can arrange that. We can do that. What the hell do you want to see it for? You're flying the last of the sports cars, and that's not a sports car. So, but it's a huge airplane.
Yeah.
No, but I never flew it, no.
Okay. 106?
Yes.
117?
No.
Okay. Let's see. Is that it for the Fs? How about A's for fun? A4?
Yes.
A6?
No. No.
A7?
I think they had a 2-seat A7 once.
TF or TA7? I think.
I don't know. Maybe
Yeah.
I did once, but
All
it's
right, you
like
have to check the logbook. How about A10?
no. no.
Okay. Let's see what else is there in the A's. But you've definitely flown a lot. Have you ever tried to count how many different aircraft?
No. Well, I sort of estimate 80 types that I've flown.
80, yeah.
But at NASA, we had a great rule that we assigned 2 people to a project. Like the 106 was there because we towed it from a C-141 on a big tow line.
An F-106?
A 106.
You towed?
Yeah, but we're demonstrating the concept because people were talking about towing rockets up, a rocket, and lighting them up,
Okay.
and saving the gas because they tow them up. But when they're finished the program, then all the people in the office, if it's possible, that's how the 114 happened. They get a flight so that's how I got the 106 and the the F-14.
All right.
Because we had the early model, earliest F-14, and starting it was some sort of magic process. And I remember something didn't work, and I'm saying it's not engaging or whatever. And then a voice came over, push on something else that seemingly had nothing to do with the starting, push on that one. And I did, and it worked.
Boy.
Yeah.
I know we talked about the X-29, X-31. Any other X jets that we didn't cover?
Well, the 22 is an X.
X-22?
Yeah.
Okay.
So the interesting thing for me to go, not to philosophize too much here, but say as you get older, you start to be a has-been. So the line, you want to draw the line so you're not always telling people what you've done, and that's not my purpose.
Okay.
But quite often in conversations, they come along and say something about an airplane or whatever. They don't even know that I was involved in it. And I'll say, well, yeah, I did that, or we did that, and this was learned. Not trying to tell them what I did, but you have to be careful of that. And so now you want to still be relevant. That's a key word as you get older, to be relevant, not artificially relevant, but doing consulting, like I mentioned, doing that as a luncheon talk. I've never done a luncheon talk. So I put in a few more videos and so on. But I went to MIT 5 months ago, I guess. They have a flight test operation at Hanscom Field. They do really advanced technology, electronics. Now, they tell me that Eisenhower started that.
Wow.
We have companies, we have organizations that do work like Hanscom Field, like MIT, that are funded through the DoD in some way. They don't have to follow the DoD bureaucracy or the policies and so on, but they are a special not-for-profit group. That means people that really care about the technology and not the stock options, that's not their driving force, have a place to work where they can do their skills. So I went there because one of their departments is the flight test for the other departments. Sometimes they want to take things into flight. And I was trying to figure out, I go there and do it. I just talk to people one-on-one, just a reporter, if you like. And I was asking them, trying to get an idea what they do. You mostly carry things on board that you think you need to get airborne. Yeah, but it turns out that they have large antennas that they put on the sides of airplanes, 19 feet long. It's pretty big. So that gets into all sorts of like flutter and all manner of stuff. So they have the full gamut of it. And they do, and I was not privy to exactly what they do, but they do the farthest out development that you can imagine that people get the benefit of. Yeah. So it's nice to talk to that kind of, and it's nice to see a very good organization that they do. So.
Rogers, I want to pivot to this segment where the folks that support the show financially on a service called Patreon, they get to know that I'm sitting down with you and I say, check out his bio. He's all over the web. You can learn what he's done and what he's flown, and we just took a journey through that. And so they pose these questions that I like to pose them to you. The first is from Joe Kunzler. It's regarding the X-29. Why do you think forward swept wings aren't more popular?
Yeah, we kind of touched on that because they can do it other ways now.
Okay.
With
leading
advanced
and trailing
wings.
edge flaps.
We even did not on that, but we did a mission adaptive wing. They actually flexed the composite surface with the appropriate structures inside to change the camber. So they can do it quite effectively with trailing and leading edge devices.
Okay.
Yeah.
Speaking of that, we typically stick with military aviation, but as an airline pilot, I always wondered why someone hasn't come up with winglets, which they all love now, that can go down when they don't benefit anymore. And I think I'm starting to see that. I forget what airplane it was. Might be a new Airbus or something. But anyway, put the winglet up. I think it's best for climbs and descents and not when you're cruising or something.
Yeah, there's
like that.
a certain time it's not.
Yeah. Anyway, moving on. Mike Soldow, who's right here in San Diego, says, were you the lucky pilot that flew the last ever SR-71 flight that Saturday in 1999 at the Edwards Open House?
Yes. Yes, and I wasn't expected to be the last flight. We hadn't flown it for a while, the SR, for a month or so, or a couple of months. And so myself and one of our backseaters got to fly on Saturday. So we went overhead at 3.2 Mach, and you can let people see you by dumping fuel. Oh. Now, some of my Air Force buddies would tell me that when they went by, in the early days, they went by Murmansk and up. Obviously, they never went closer than 12 miles. Yeah.
Of course.
The fields up there, the airfields, are only operational in the summertime. So in the springtime, they'd start flying, and anyway, they would sometimes dump fuel to just tease them, say.
Let them know they're there.
They could see us and say, "You can't touch us." Yeah. The reason it was the last flight was because the SR, it doesn't have fuel bladders in it. It has fuel cavities that they seal in the wing and the fuselage. So when they heat up, they heat the structure up and they cool it off, heat it up, cool it off. Eventually they get more brittle and they get more cracks. And the first time I flew out of Palmdale, I can see it now, the crew chief came in. By the way, he had a raincoat on because the airplane leaks on the ground because of all these cracks. It's not very volatile. You could have a collector on the ground, you throw a match, it won't light. So he said it's pretty good, and I went out to the airplane. I'm looking. There was one stream that went from the airplane, almost a steady stream to the ground, not drops.
Wow.
But so it leaks all the time. It leaks in flight. If you see the famous one that we gave to the public over the Sierras, you can see all the lines, but it's fuel. They're fuel lines. Yeah. So anyway, we hadn't flown for a while, and the next day the other crew were going to fly, and they were already out in the trailer getting suited up. They got suited up. And I went out with one of the engineers in a truck, and somebody stopped us and said, we got a really bad leak. And it was a real gusher they were having. But in the air show schedule, they couldn't get to it, the panels. If they could have, they couldn't get to it in time, so we lost the slot. Then they couldn't do it. But if they could have, if they could assure themselves that it was just coming from a crack, we would have gone.
Okay.
And they because it leaks all the time.
Did
It
that
gets
crew
worse.
think they were going to be the last
Yes.
flight? Okay.
Well, I don't know that we knew it was going to be the
Okay.
last flight,
All right.
but yeah, for me, then I worried for a day and a half because at the end of it, we did 3 flybys. That's not our habit pattern. And if we're lighter on fuel now because we've been up to 75, 80,000 feet. And you come by, and now I used to tell people in the various guard organizations we do flybys, do not hear the roar of the crowd because there are like 300,000, 350,000 people there.
Wow.
So you come by in an SR now, and you light the burners at those weights. First of all, when you light the burners, the low fuel pressure light comes on because it's can't handle the surge, and the acceleration. You realize the SR is 500 knots max speed, 500 keys up there. It's going like 450 keys, equivalent airspeed, to equivalent on sea level. But that's not very fast by our standards. So, but you go from like 250 knots or 275 to 450, just like you can't get it back fast enough. And then I wanted to also pull up to slow down.
Right.
And I worried that I pulled up because it's also not the G levels that are allowable at speed is 1.75 Gs.
Oh, that's not much.
But down low, it gets up more like 2.5, maybe 3 at special conditions.
Okay.
So I worried that I had over-G'd it, but it turns out I didn't. It was just that unfortunate leak that caused the problem. And then they shut the program down
Yeah. Wow.
because we couldn't get that clearance to fire the laser.
Here's a fun one from Niels Hansen. Are you more proud of what we have achieved in aviation over your lifetime or more excited about what lies ahead?
Yeah, that's kind of tough. I'll tell you one thing that I use all the time in talks.
Okay.
I would say especially in schools, we did that at NASA. I'd say, anybody here know the first line of David Copperfield? And of course, I don't think it was maybe one person in my lifetime knew that. The first line of David Copperfield applies in that the first line is, I know not whether I shall be the hero of my own life or whether that station will be held by someone else. The point being, to be a hero of your own life is not telling other people what you've done. It's nothing about boasting. It's about inside you. Have you, maybe you haven't done everything, but have you worked? So back to your original question, what did I want to be? I wanted to be a test pilot. I wanted to be a pilot and an engineer, and the pilot side, of course, a test pilot. Why? Because I love my uncle, not because I'd ever had any experience in flying. So I can honestly say, inside here, I'm really happy. Outside, I still want to participate. I'm excited by things that I hear and see, and I want not to be somebody that's up there boasting about what they do.
The good old days.
The good old days. So that's a long-winded answer to that.
Well, I wish I'd have saved that one for last. That was a good one.
Yeah.
John Clark, what message would you give Kelly Johnson and other aircraft designers to make their products better and safer? Did you ever meet Kelly Johnson?
I never met Kelly Johnson. I met Ben Rich a couple of times. In fact, one time I thought he was the entertainer at the hotel where the SCTP was because I was in a group and he came along and they have a president's dinner for sponsors and a select few from SCTP. They're all in tuxedos. And I was fairly new at NASA, and I was with guys that had flown the SR on the previous time at NASA. So he leaves, and I go, who was that? They go, you didn't know that was Ben Rich?
And can you tell me who Ben Rich is? Because I should know, but don't.
He's slight in stature, but he's really, really someone you listen to, and he's got several jokes he told there that.
But was he involved in the development, or?
Oh yeah, he's given. Oh, I'm sorry.
Yeah, sorry.
He is always referred to being the inlet man.
Okay.
That he was. Now Pratt and Whitney and others, don't get me wrong, it wasn't all Lockheed, but that that was a real breakthrough, the inlet,
Okay.
for everybody, including Russians. I was either Tupolev or Anatov. We didn't talk about, I got to fly 7 flights in Russia.
That question's coming up next.
Oh, okay. So anyway, I was there when, I think it was Tupolev, or it could have been Anatov. After the wall had come down, they were cleared at Edwards, and he's walking around the SR. This is a designer, and he's looking. If you look at the leading edge of an SR, it's sort of ethereal. It's a shapely thing. It's not, you expect it to be, hewed out of stainless steel or something. So he was jabbering nonstop to his interpreter, but I think the gist of it was he couldn't believe the shape of this airplane and so on. But he'd obviously heard a lot about it.
Yeah.
So, but I would not give any advice to Kelly Johnson / the Skunkwork of his days.
Okay.
I would advise all the other people to go study how he did it. He ran the place, but he realized that to do development rapidly, you need to test early and often, but you need a select group freed up from, if there is a bureaucracy and a structure that you have to follow.
Collateral duties,
or
maybe.
the HR department.
Mm-hmm.
First thing I would do if you ever put me in charge of a large corporation, I would talk and say, HR, you need to understand one thing. You work for all these other people here. You are not
They don't
on an
work
equal.
for you.
They do not work for you. You follow go get them what they need.
Mm-hmm.
But too often it gets around the other way.
Yeah.
Anyway,
No,
nobody's asked me to do that.
Yeah. Well, not too late. Let's see. That was John Clark. Jevin says, when you flew Russian aircraft, and we didn't cover that in the in your bio, but when you did, and you can talk about this, in what ways did you get to push the envelope in them, and what did you learn in doing so? So give us a little background first. You had a chance to go over for a number of months.
Yeah. So what people at NASA had wanted to do is, first of all, the wall came down, and there was some interchange between the Air Force and other military people, possibly. And so Edwards was cleared to have people fly certain things. But NASA wanted to have an exchange. They wanted to particularly understand, how do you do high angle of attack testing? What methods do you use? Because we had both, to some extent, the X-29, but largely the X-31. How do you do that? So NASA headquarters tried for some time to set up some kind of exchange, and it never evolved. And my director, Ken Saleh, is a great man, great leader. I was fortunate to work for him for most of the time I was there. He retired from NASA and went to work for, started a company with a lady that was worked with Arm & Hammer in importing lots of raw materials. Maybe like the titanium that's used in the SR-71 came from Russia. Yeah. So he talked to her. He got in this company. They're making ejection seats. Because the Russians, when we talked to them and told them when they came, the other part of the exchange, and said, they're going to fly an F-16, the seat is only good up to whatever it is, some number, not the full envelope of the airplane. And he said, wait, that's a number one rule in our seats. All have to cover the total envelope of the airplane. So anyway, he talked to this lady, and she took about 2 weeks to set up this exchange, because she knows everybody in Russia. And when later on they took the Tu-144 and put different engines on it, put newer engines, she was involved in setting that up.
Oh.
One of the things she did was took all the money that was to exchange, she took it and wrapped in newspaper with her to give directly to somebody, because if they sent it over there, it would never get there.
Wouldn't find its way to the right place.
So then the funny part of the story is, we had selected one of our pilots that was going to go on this. We were waiting to see what's going to happen. It comes, the date, we're going to leave in 2 weeks or something like that. And he, meantime, has had an operation on his foot for a wart or something, and it got infected. So he's limping around the office. And I said, oh, you can't go on this thing with limping. You can hardly walk. So we need to delay it. So I passed that on. We need a delay 3 weeks. And yet, can't be done. Got to be done. Well, I don't. And so then I looked around the office. Nobody ever believes there was no one else that could go except me, truly. And then I said, well, I don't have a visa. And she came back and said, you're not going Friday, you're going to fly on Saturday. You'll have the visa on your desk on Friday afternoon. Oh. Which guy came and gave me my visa. So I went over there and I flew the Su-27 like twice, the MiG-29 maybe 3 times, MiG-25 once, and L-39 once. And so that was, we wanted to look at high angle of attack, and we wanted airplanes to be recently inspected, the big inspections finished. And there wasn't, in the time I flew 7 flights in 10 days, and never saw light. And I flew in the front seat in every airplane.
Never saw light?
No, a warning light. Nothing ever went wrong in the whole time. But you have to understand, and you could talk forever about this one, the place, Gromov, we worked out of Gromov. Gromov is a research institute.
Okay.
It's right next to Sagi, which is where all the wind tunnels, they have a huge wind tunnel complex.
Okay.
And it's out at Ramenskoye, just outside Moscow. And so they have, I'm trying to get my train of thought here. That's where they developed all the MiG and Sukhoi. They all have places there. So the Gromov Institute is like NASA. The toilets didn't work. The lights were, half of them worked. It was a shambles. The floors hadn't been cleaned in looked like 3 years or whatever. So, but the airplanes, and the MiG-25 I flew was the same one that chased the Buran. It had been outside, I think, every day since then. And so it was looking like an airplane that had been outside for months, years. Wow. And also you sit in a different they have another cockpit put on, so you're separated from his cockpit. You're up in the front. You're not, so it's even more tricky to be in that. I work with a man that Anatoly Kwacher, his name was. If you've ever seen the picture of, I think a MiG-29 crashing at the Paris Air Show. Mm-hmm. So he departed the airplane, and you see the airplane just entering the mud as he's landing, not very far away. Yeah. That's Anatoly. He's a great pilot, and so you could talk forever about it, but we wanted to see high angle attack. So they modified the MiG-29 back to the original state that you could do flat spins. Get out of flat spins. Okay. Otherwise, they have an angle of attack limiter, and the Gromov people were very disparaging of the Russian Air Force. That one had 26 degrees and one 29. I forget which was which, but they were just saying we don't need a limiter, and you didn't, because you could see everything that was happening. A little yaw, you can put on a little rudder. So they had written out exactly what we could see, and showed us everything. So we would, like MiG-29, you'd say, let's assume that the sun is a target over there. Okay, now I'm doing the flying. I had to ask him we did like 8 spins in one flight, and I had to say, wait, can we stop for a minute? But looking at high angle of attack, the limiters are off. Now we can fly with no limiters because we're flying at Gromov. And we say and you just look over at the sun and pull, turn, roll, and pull as hard as you can. We're going up to, 65 degrees angle of attack. Yeah, and there's maybe a little yawing in the nose, but no departure. So that's the kind of flying we were doing. Su-27 is, I think, F-14, huge airplane. Yeah. And when we first took off, first day, many stories, but it was about 1,500 feet overcast. First day we were going to fly. I got suited up. I had partial pressure suit, and Russian. The lady that was gave me a Russian jacket, looked at my U.S. winter jacket, said, "Yeah, take it off." Wasn't good enough for the cold. Anyway, he asked me, his son was about 13, was there, and they didn't fly very much this time. They were previous, in the years before, they flew thousands of hours in a month. Anyway, can I take it for a minute? Because he did air shows to make money. They made money at air shows. They got only 1/4 of their budget that they traditionally got.
Oh.
They flew transports in with for money. And I said, sure, you can have the airplane. So we did an air show in the SU, right at 300 feet or so. Really impressive. And afterwards, the chief engineer said, "Is that okay with you?" I said, "Sure, I'm not going to be doing that." But it was very impressive.
Yeah.
So the airplanes were all impressive. And the SU it's a huge airplane, so it does everything slowly so you can really see and counter it. And the MiG-25, I think before I went to 68,000 feet.
68?
In a zoom. So I'm going, well, what's the min speed we can go to? Oh, you got to tell me a min speed that we're going to go on the zoom. And we did. We zoomed up, and I don't know, 250 knots maybe, or 220 or something was min speed, and pushed over. And I didn't fly with Anatoly in the MiG. I flew with a young man who spoke perfect English. His father had been a test pilot and died in a crash. Oh. But the next morning, I came in, and this young fellow says, "I made a mistake." He made a mistake. "I made a mistake. I'm sorry. I didn't run nice." I'm going, what? It was a good flight. It was a very interesting flight. Because we came down and did a loop at a 10,000-foot loop in the MiG-25 with two hands. You have two hands on a stick. The forces are so heavy. So what he said was, he asked me how did it go and how impressed I was with Gromov and the people. He said, "We had permission to spin down from 50,000 feet to roll out at 10 or above and then do the loop."
Thanks.
I said, "Are you kidding me? We're going to spin the MiG-25?" He said, "Yeah, we had permission to do it, and I forgot it. That's a quick way to get down." And so, anyway, they treated us very well, and I said at the end of my talk once on the Russian experience, if I was going to war, I'd like them on my side because they know the fundamentals. If we asked anybody to write out the equations of motion of an airplane, just give them a sheet of paper, one of those engineers could write it out. Didn't look in a book, write it out. Because they didn't have computers. Now, when they came to our base, that's what they marveled at. You have so much. And we even had instruments that measure angular acceleration. They said they'd been working for 5 years on that. But he said something at the end. He said, maybe we can learn from it. Maybe sometimes you can have too much. And you forget that you need to know the basics.
Yeah.
Or at least be familiar with them.
Yeah.
Anyway.
All right. Last question is from Jim Gundog. What are the benefits of unmanned or remote piloted aircraft in the test arena? Now, before we get to that, though, everything we've talked about so far was you in the cockpit, generally speaking, a lot of different aircraft. In your quote-unquote retirement, have you been dabbling in unmanned or?
No, I was the test pilot at Grey Butte for the MQ-9 for the last 11 years. I'm not flying anymore there. That's a whole other story, but no, it's time that I didn't fly anyway. But because I'm working for the Air Force.
Okay.
And so, yes, I was a line pilot and a test pilot and the contract director for that work, because it's still going on. I was there yesterday.
Oh, wow.
Yeah, because I go there every once in a while. I still get the safety thing. I still get some hours to do some safety consulting with them. But the answer is yes, and I have experience with Joby. For example, they could fly their airplane remotely first, easily, without all the paperwork of putting a man in it.
Mm-hmm.
And people can, when you have that flexibility, it's pretty It's very worthwhile. It's very worthwhile. When I first went to the MQ-9, I said, why don't you put there's room. You don't need the KU antenna in the front. You could put not for public use, but you could put a pilot in there, and that means you could make some changes and fly. You don't have to, because it's hard to fly in national airspace. It's much more paper heavy to fly in the national airspace remotely. Now at Grey Butte, we fly to Edwards, restricted area, to do all the testing. And there is a special permanent NOTAM about the track we're going to fly up there.
Sure.
So you can take advantage of flying remotely in some cases. Yeah.
So to Jim's question, it's nice that you, on these risky, maybe first flights, can do them without a pilot. Is that
That's possible. We've much more experience in building autopilots and so on.
Yeah.
And you know, the airlines being a case in point. You know, how many decade we could take off from some airport. You could actually take off, maybe put it at the end of the runway. I don't know, but to fly the whole flight and land. Not today. I mean, you can do much more than that. But
right.
So yeah, but there's a lot of ego gets into the business of, certainly with the Test Pilot Society, even with whether people that are doing testing, like structural testing or flight control testing, or any kind of testing in a remotely piloted vehicle are not, they're somehow not qualified. Now, I think they should be qualified pilots, but people that do that, pilots that do that work, should get credit when they do the testing, because they're following the same principles. In fact, the MQ-9 tests under the authority of Edwards. So when we have a test plan, it has to be approved by Edwards. But that's happening more and more, that sometimes people want to take advantage of those things to do it better, faster, cheaper.
Sure.
So for good reasons, when you have good reasons, you can be flexible that way and use technology appropriately. Yeah.
Well, and Jim's question is a good segue into sort of tying this all up, which is, you've seen over your decades of experience a lot of changes, I presume, in the way things are tested. What do you see, and you're still involved, right? So what do you see the future for the testing of, whether it's aircraft, manned or unmanned, or maybe even NASA, based on your experiences there? But with what you've done, what do you see the future for those different parts of your life?
I believe the challenges for leadership. There's a challenge for everybody that's working. Everybody can be a leader at some time every day.
Right.
But the challenges for upper management leadership is greater than it has ever been. And that's because, we have new technology, but some of it's more complicated. If you think about the F-35, I won't share any credit for that, although I was involved when they first were doing the proposals, and I was stunned for the Air Force on a panel that visited when they said they were going to have an active stick and an active throttle. I go, are you serious? You're going to build a new airplane and you're going to... Active stick means you can change the force displacement relationship or the dynamics of the field system online according to the configuration, according to the where you are in the flight envelope. And the throttle the same way. You can, but it has to be sufficiently redundant to be reliable. And they said, no, that's what we're putting in. We're going to go for that. Well, they also now, because of technology, they can use a scheme that they do use called dynamic inversion. Basically, it means you have a pretty good idea from various new technologies of what the characteristics of this vehicle will look like, what the equations of motion will be for the airplane itself, and you also have some desire what it should be for various things. You think of the B model has got to land vertically, for example. Mm-hmm. And so how can we do that? Well, dynamic inversion requires you to know the model for the airplane, the matrices that describe the control system and the model, and then you cancel it out internally in the system, and you put in the matrices that you want. So you couldn't do that. You didn't have the capacity. You can do that on the airplane. Now, I don't know whether you do it every instant of time. I don't know the specifics. I do know one of the short courses that I was teaching part of it at the National Test Pilot School, that I'm proud to report, is that one of the men that was involved at the Skunkworks was, for some reason, in this course. I don't know why, but he was. He's a great tall fellow. And I was standing on the stage, and he came in and sat down, and he said, you're Roger Smith? Are you? We have a criterion that we developed at Callsign, Cornell Aerolab, called the Neil Smith criterion. In the early days of fly-by-wire, it was how you could look at, somebody designs an airplane, you can look at it and see whether it would be, from a fighter point of view, a good airplane or not. It was pretty important because they were, in those days, very complex. So anyway, he asked me that, and I said yes. He said, let me shake your hand. So I presume that maybe it's digitized now. You can run a digital computer. They might have used that. I'm just saying might. So anyway, go ahead.
All right.
Sorry.
No, that's okay. We're just talking about the future of all this. What about the future? Future for you? Are you still going to be keeping at it? You've been at it for a long time. I'm not trying to call you old.
No, don't do that. But no, I am old, but I'm. My wife worries about me being old, but most other people don't know how old I am. But Billy does. He can tell you.
Okay. So
I'm older than Billy. I'm 22 years older than Billy. Yeah. So
anyway,
that's why I always refer to him as I'm the mentor. I started when he was young. But no, I like to be involved because of the same reasons before. I have a passion for it.
Okay.
It's not ego-driven essentially, but what I talk about now are the intangibles more than the details. Like we can do, fly-by-wire dynamic conversion. We were going to put that on the F-18. It had never flown. Just about the time I was leaving NASA, we were going to put it on an F-18 because we had an F-18. We had access to a computer, but it now flies in an operational aircraft. So that's just the beginning. But I'd like to be involved with trying to teach about teamwork and leadership.
Okay.
And it's few leaders that ask for that kind of feedback.
Yeah.
Some people do. I worked with Boeing in 2011, 12, Dennis O'Donoghue. He hired me to maybe 3 or 4 days a month, or a week a month I worked for a couple of years. I went to 6 or 7 of their detachments, or like Pax River. I went to Pax River.
Okay.
I went to Seattle twice, where I did what I learned how to do what I do, which is just talk to, if you bring me into the organization, I'll list the people I want to talk to if I know them, or what they do. And I said at Boeing, I want to talk to a mechanic, like the 787 was in test. They said, why do you want to do that? No, I want to understand how you work. So I ended up talking to the head of the union, and I learned a lot. I said, if you believe that what you write down, that this company believes safety is number one, they don't believe it. So that's important.
Yeah.
Got to get them to believe it.
Yeah.
By demonstrating it.
No kidding.
It's nothing to do with this was 2011.
Sure.
Yeah. So.
Do you still fly?
No.
No desire, no urge.
No,
same thing, but
no, I don't.
Okay.
I would certainly fly with anybody, but I truly believe in being proficient.
Okay.
You need to be proficient. So if you're with somebody, if you're not, then when the unexpected happens, are you going to have excess workload capacity? Not likely.
Yeah.
So there are lots of stories about that, but
Sure.
lots of examples in airplanes with that. When people jump on the stick and do something like driving a stewardess up into the ceiling, and they killed a couple of people over the Pacific, and they could have just put their hands on their head for a while, like the A330 that crashed in the Atlantic.
Yeah.
If they put their hands on their head for a minute, looked around, they wouldn't have hit the Atlantic at 10,000 feet a minute.
Yeah, instead of holding
40
full
degrees.
aft the whole time.
Yeah, practically speaking, full aft the whole time. Well, I talked to the A350 now has alternate airspeed. I'm not taking credit for that, but I talked to right after that happened at a meeting that I was talking at, and the chief pilot for Boeing said, I think you're telling us we didn't design the autopilot right. We didn't have to turn off the autopilot. Why did they did in the A330.
Right.
As soon as they got the miscompare and airspeed.
Right.
You didn't have to do that. I said, that's right, didn't have to. And why would you ever take out the angle attack limiter, which they did, because it dropped it down one level in the autopilot. So, but I still like to preach, as you can see.
Yeah.
So answer is yes, I like to be involved.
Okay.
But I have a choice now. I can work if I want to.
Okay.
So
Well, I have a scenario, and it's going to take some build up, so bear with me. So you say you don't fly because you're not able to maintain the proficiency. So I want you to imagine, Rogers, that you can either flip a switch or take a couple weeks, whatever magic,
Yep.
little check mark. But then you walk out, let's say here at Gillespie Field, where we're using the studio at the Circle Air Group, FBO, and there's, bear with me, every aircraft you've ever flown.
Oh,
All right.
good.
And you can, like I said, you can flip a switch in your mind and you can say, all right, I'm going to get in that one because I just want to go goof around and cloud surf for an hour. What airplane are you walking towards?
Well, it's either the F-16 or the F-18.
Really?
The F-16 because of the cockpit and the visibility you have. You're really out on the end of an arm.
Oh, yeah.
And you don't have anything in front of you.
Yeah.
The airplane's really part of you. The F-18 because it's, to me, and what I've flown is a very honest airplane that can do most everything. And I have a lot of time in it. Yeah.
Yeah.
So.
Great. Well, we always finish with call signs. Now, you allowed me to just call you Raj. I think we can figure it out where that came from. Was there anything else ever that people
I
called
only
you?
had one in the Guard.
Okay.
I had a Guard commander who's still a good friend of mine, that very great leader, but he had a nickname for everybody, and he used to call me Nipple Neck because I had a protruding mole on my neck, which I
Okay.
immediately had removed.
After he coined that
Yes, right.
phrase on you?
So that went away, and so they called me Rouge because I'm from Canada. They claimed that that's an extension of Raj.
I see.
I didn't
Rouge.
have. Some of the nicknames people have are amazing. You like to
yeah.
hear the stories of how they got them.
Well, we had an episode dedicated to call signs, but according to the guest who was on that show, it's gotten a bit more political now. You have to get approved to have call signs because it gets, it's
Well, they have some of them there.
they're a little childish,
Yeah.
salacious.
But when I was in the Guard, the Air Force was not allowed to have call signs.
Really?
The Navy had call signs, but the Air Force couldn't.
All right.
Yeah, we wanted to have even the call signs for the airplane. They wouldn't. You go down to Tyndall and we'd have our own Rhino 1, 2, 3, 4 or something. I can't do that. You got to wear your scarf while you're flying.
Ascot?
Scarf. Ascot. And so my squadron commander cut up, the colored paper you put on for parties on the tabletop. One morning he cut all that up in strips, and we all came into the briefing with our little ascots.
Fake ascots.
They didn't appreciate the
Oh,
humor.
boy, I'll bet.
Yeah.
Well, like I said earlier, humor is a big part of this career, I feel like.
Yeah.
You got to do it. Well, Rogers, you've been a good sport, and I've been chasing you for a while to get an interview. Thank you very much.
Well, I thank
'Cause
you.
You're all over Europe, and you got a place up in Mammoth, right? So
Yes,
you
we
get
do.
up there a lot.
Do you ever get up there?
My family was just up there for Memorial Day. There was still snow. I was not
yeah.
able to go. I was flying, but I love it up there. I'd like to take my fly rod up and come visit.
Yeah, Smith, you know that name. So I think it's in the phone book. Well, you got my cell phone.
That's right.
Yeah. So yeah, please give a call.
Awesome. Well, thanks. This has been a lot of fun. I definitely learned a lot, and I stick to what I started with at the beginning, which is your name belongs up there with all those other guys, and you've certainly seen and done a lot. So on behalf of the listeners and the viewers, thank you.
Oh, thank you.
Hey, thanks for watching this episode of the Fighter Pilot Podcast. I hope you enjoyed it and learned something new. I still do every episode. Now, as a quick reminder, we try to explain all the jargon, but in case you missed something, head on over to fighterpilotpodcast.com, where we have a glossary of all the different terms we use. And while you're there, check out some of the cool merchandise that we offer. For additional content and to help support the show, please go check out our Patreon page. We'll see you next week.